So this is pre-algebra lesson 3.5. This is going to be like a 3-minute lesson. Here we go. It's solving equations by adding or subtracting decimals. Let me give you an example here, okay? I'm going to show you this. So I'm going to go x plus 7 equals 10. Okay, we're all up here looking, right? X plus 7 equals 10. What do I do here? Line down the equal sign. Then what? You're looking to see if the variable's happy. Is he happy? No. Why not? Not alone. Okay, so then who's with him? The 7. What's the 7 doing to him? Adding. How do I get rid of plus 7? Minus 7, x equals 3, right? And we're done. All right? Agree? Okay, here we go. Here's going to be the tough. Here it is. X plus 2.3 equals 5.8. Okay, here we go. Line on the equal sign. Is the variable happy? No. We go minus 2.3, minus 2.3. The only thing you have to worry about is nothing really, is making sure that when you're adding and subtracting decimals, what do you have to make sure you do? Line up the decimals, and it's 3.5. So the only difference here is that we're doing this with decimals instead of whole numbers, right? I mean, if you want to get technical, we could go x plus 1/2 equals 3/4. Right? Watch. You're watching? We could do this with fractions. Line down the equal sign. Minus 1/2. X equals, what's 3/4 minus 1/2? 1/4. And we're done. Nothing changes just because we're dealing with decimals, or nothing changes just because we're dealing with fractions. You just do it. Right? You just do it. The only thing you have to worry about is you have to make sure when you're adding or subtracting decimals that you line up the decimals. Right? Now, another thing, what about this? I'll give you one that is slightly funky. We'll go 2.5 plus m equals 1.8. So here we go, line down the equal sign. Is the variable happy? No. We've got to do what? Minus 2.5 minus 2.5. This is the weird part, because technically, can I just go 1.8 minus 2.5? Can I just start subtracting down? No. You have to understand where you're at on the number line. I have 1.8 and I'm taking away 2.5, right? What is my answer going to be? It's going to be a negative. As soon as you realize that it crosses 0, what can I do to this problem? What can I do here? You turn it over. Nope, you turn it over and you subtract them upside down, knowing that it's going to be a negative. And you go 2.5 minus 1.8, and it comes out to 0.7. We know the answer is negative 0.7. Does that make sense? But you know, you have done this before. You know how to do this. You just have to keep it in your head, right? As soon as you're subtracting and you're crossing 0, or as soon as you're adding and you cross 0, you can flip things around. You know what I'm saying? Like, you subtract, you just turn them around, subtract, and know that what the answer is going to be, whether it's positive or negative. Make sense? Make sense? Does it?
Yes. Yeah.
I hope so. Let me look and see if there's any more difficult ones than that. I mean, okay, they also might give you this. They might give you a, x minus a negative 3.8 equals, 10. What do I have to do here? Line.
Plus 3.8.
There's our red flag, right? Before he starts actually doing anything, we have to clean up the house, right? And that is not cleaned up. We have to deal with that red flag, which makes us one giant plus sign. So it's x plus 3.8, which is minus 3.8 minus 3.8. Where's the decimal on the 10?
Halfway 0.
Right? X equals 6.2. Make sense? On any time you're doing equations, Carla, you got to show your work, and you got to show it my way, right? You have to. I don't care whether you can do it in your head or not. Not the issue. You've got to show your work. I don't give you a ton. When the ones I do give you, you have to show your work for me. Got it? If you don't show your work, what's the case? What do I call it?
0.
It's late. right? It's late, and so, or 0, whatever. If you don't turn it back in, then it's 0. Okay, got it? All right, let me give you your homework. This is not... Okay. Oh, I was supposed to do both. Okay, I'll quickly, we're going to jump to the next one. Solving the equations by multiplying or dividing. Nothing changes here. What about this? What if I have 1.2x equals 6? What do I do with this? Line down the equal sign. Is the variable happy? No, why not? He's being multiplied by 1.2. What's the opposite? Divide by 1. Multiply by 1.2. Divide by 1.2. Divide by 1.2. What is 6 divided by 1.2? It is 5. Does that make sense? Or, you get a more difficult one. Let me look at a really tough one here. Here we go. 6.4x equals 0.0. Not 0.0. 0.2816. Line down the equal sign. What do I do? What do I do? Don't ask me that question now. What do I do? Divide by 6.4. Divide by 6.4. You're in pre-algebra. I don't care. Use a calculator here. Whatever. X equals, what is 0.2816 divided by 6.4?
I think it's 4.
Nope.
2.
You're just going to take a guess? What is it?
0.44.
0.44.
It's not even close.
Right? And we're done. 0.0444. 0.044. Right. There it is. Does that make sense?
Yes.
Nothing changes. What about this? What if I have, y over 1.5 equals 2.1? Line down the equal sign. Multiply by 1.5. Multiply by 1.5. Y equals, what is it?
3.15.
Makes sense. Nothing changes here just because they're decimals. You just have to deal with the decimals. Okay? Makes sense? Okay. Your homework. Now I can give it to you. I forgot that I combined those two because they're kind of easy. So page 150, 1 through 29 even, and page 154, 1 through 32 even. Let me make sure that's good. It's a total of and you can use your calculator. Okay, here's a rule. I'm going to talk to you about a rule that you need to understand. When do you put your answer as a decimal? So you're in algebra now, so you need to understand this rule. You only, listen, pay attention to this rule right now. Kyla, I want your attention with me. When do you actually, listen, if the answer came out to 4.5, when do you leave it at 4.5 or when do you put it at 4.5? There is a rule. What's the rule? Anybody have any idea? The rule is, since you're in algebra now, the only time you give me a decimal as an answer is if they tell you to round to the nearest whatever, right? Or if there's a decimal in the question. If there's not a decimal in the question, and they don't tell you to round to the nearest tenth or hundredth or whatever, then you have to leave your answer as a fraction. Listen. Stop. I need you really to listen. It's important because you're not going to do this right if you don't listen. And I'm telling you, how's this? They're just wrong if you do it wrong. So you might want to write this down. The only time you give me a decimal as an answer is if there's a decimal in the question or if they tell you to round to the nearest whatever. Otherwise, what do? You leave your answer as a fraction. Do you understand? The real point here is that you don't change it to a decimal unless there was a decimal in the question. Make sense? So, for example, If I have 1.2x equals 6, how are you going to write your answer? Or I'll put 6.4. What is your answer going to look like? I don't want to know what the answer is. What's the answer going to look like? It's going to be a decimal. Why? How do you know it's going to be a decimal? Why? How do you know? Because there's a decimal in the question. But if I give you this, 3x equals 4, watch what happens. Line down the equal sign, divide by 3, divide by 3. You could, if you were going to get your calculator out and do 4 divided by 3, it would be 1.333333. Do I want you to put 1.33333? Do I want you to put 1.3 with a line over it? No, why not? Because there's no decimal in the question. You don't change it to a decimal unless there's a decimal in the question. What would you leave the answer as? Is you would actually leave it as 4/3, or you could leave it at put it 1 1/3, whatever, but you don't turn it to a decimal unless what? There's a decimal in the question, or they tell you to round to the nearest. Got it? There it is. You don't. Since I'm letting you use a calculator, this is no big deal. Here's your questions. There's your assignment.